You're welcome to this class, and in this lesson, it's more of a basic lesson. So in this lesson, we're going to look at atoms and everything that relates to atoms. So we look at atoms, molecules, and ions. Then we look at the atomic theory. Then we look at the relative atomic mass and relative molecular mass. So we look at the number of moles or number of particles. Then we round the session up by looking at calculations involving molar masses, which is your how to calculate the empirical formula and your molecular formula. So we are looking at the definitions of atoms, molecules, and ions. An atom is the smallest particle of an element which can take part in a chemical reaction. Or you can say an atom is the smallest part of an element that can ever exist and still possess the chemical properties of that element. So that is an atom. So let's say you have a grain of sugar, or you have a cube of sugar, for example. You have a cube of sugar. If you divide that cube of sugar into particles, and you pick each particles, you divide each particle into subparticles until you get the smallest one. So that smallest one is an atom of sugar. So that smallest one can also take part in a chemical reaction. Physically, it might not be further divisible, but chemically it can be divided. So that is an atom. The smallest part of any substance or any element that can take part in a chemical reaction is called an atom. Then we look at a molecule. Now, an atom is different from a molecule in that a molecule is the smallest particle of a substance that can normally exist alone. Take note of the word exist alone, and still retain the chemical properties of that substance. So an atom cannot exist alone, but a molecule can exist alone because you can form a molecule from more than two atoms, two or more atoms. So I have an atom of sugar. I have an atom of sugar. If this atom of sugar combines with another atom of sugar, then I can have one molecule of sugar. So atoms of the same elements might combine together, or atoms of different elements might combine together to form a molecule. So that molecule they are forming is also the smallest particle that can normally exist alone and still retain the chemical properties of that substance. So let's take example your common salt. An atom of a common salt can combine with another atom of a common salt to form a molecule of a common salt, and that molecule of a common salt can exist alone and form a chemical reaction. So why atoms cannot exist alone, a molecule can exist alone. So again, why an atom cannot exist alone? A molecule can exist alone because the molecule can be atom of the same element or atom of different element combined together, and which they can now take part in a chemical reaction. So that's a molecule. So let's look at an ion. Generally, ions are charged particles. You know, when you talk of particles, you talk of atom, you talk of molecules, and you talk of ions. So the difference between these three is in their chemical or physical characteristics. Now, why atom and molecules are not charged? They do not carry any charge, either positive charge or negative charge. Ions are either positively charged or negatively charged. And that is why we say ions are charged particles. So charged particles might mean, when you say particles, it means either this or this. So ions might be charged atom and they might be charged molecules. So there are two ways that an ion can exist. It can be positively charged, and also it can be negatively charged. When we get to electronic configuration, we look at how these charges are formed. So positively charged ions are called cation, and negatively charged ions are called anions. Okay, let's look at the foundational atomic theory, which was founded by John Dalton in 1808. So this does not apply practically again today. but of course, it still forms the basis of what the modern atomic theory is based upon. All elements are made up of a smallest indivisible particle called atom. So we said elements are made of smallest, note the word smallest, indivisible particles called atoms. So Dalton propounded that the smallest particle of an atom that cannot be further divided is called atoms. The smallest particle of an element that cannot be further divided is called atom. This theory has a flaw, as we are going to see in the modern atomic theory. But let's quickly look at the Dalton's atomic theory, then we'll go to the modern atomic theory. So the second theory says atoms can neither be created nor destroyed. Neither be created nor destroyed. This theory also comes with its own flaw. Then the third theory states atoms of the same element are alike in every aspect. In every aspect. So what Dalton is trying to say here is, if you take an atom of sugar, if you take another atom of sugar, and you compare them in every aspect, note the word every aspect, that they are the same. So then the fourth one says that when atoms combine with other atoms, they do so in simple ratio. So atoms combine together in simple ratios. So these are the four. There's a fifth one, which because of the board, I'll just make use of it. Several chemical changes result from the combination or separation of atoms. So that's the fifth one. Like chemical changes. The fifth one is chemical changes as a result of combination or separation of atom. Combination or separation of atoms. So these are the five theory of Dalton. And because researches were ongoing and a lot of people now did research, and they placed each of these theory on a scale, and they found out that some of the theories are wrong. So by the modern atomic theory. So the new theory, the result of the new experiments that were found these Dalton's atomic theory to contain error. As a result of that, we have the modern atomic theory. For example, Dalton states that elements are made up of smallest indivisible particle called atoms. The modern atomic theory have found that an atom can be divided into the proton, the neutron, and the electron. So then Dalton also states that atoms can neither be created nor destroyed. This is correct for simple chemical reaction. But when you talk of radioactive decay, so we see that atoms can be created and atoms also can be destroyed. So then the third one says that atoms of the same element are alike in every aspect. This also has been found to contain error by the modern atomic theory, because the modern atomic theory found the the phenomenon called isotopy. 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 Isotopy is a phenomenon whereby atoms of the same element, they have the same atomic number, but they have